If you have highlighters, you want to join in right now, because this is going to get a little busy. Okay, I wish we had a bit more room for this. So on page 272, make sure you write this down at the top. I will kind of go all over the booklet and write that down so you can cross-reference where can I find more of these guys, okay? Because I won't do them all. And let's just write down the page numbers. Let's write them down right here. If you want more, okay, page 273 to 274 has a bunch of them. I'm just writing it down on the margin. I'm going to zoom into that so you can see it. Right, so 273 to 274, page 282, question 7. So I'm going to circle 7. Okay. And page 286. Okay. So if you want more of this type of scenario, those are the pages where you want to go to. So it's a little bit scattered. Some are more difficult than others, but if you want to score well, then you need to have at least one of these on your study sheet on how to do them. Okay? And the frustrating part is that you might do it differently than me, and that's fine. Okay? I will just show you a way of doing it. And here we go. So supplementary angles, right? There you go. So why am I talking about supplementary angles? If you look at this diagram here, the ultimate question is to figure out, right, the height of the tree, which you're going to call x. That's what they want, right? You want to figure out the height of the tree because that's what it's ultimately asking. How tall is the tree? Everything that this question is saying is in the diagram. So if you're confused, right, did you have a question? Oh, you were just stretching? Okay. No, it's okay. So let's figure out what we can do. There is no way you can get x just like that, because if you picture any of these triangles, like there's one right here, we are assuming this is a 90. You can always make that assumption that the height is going to measure a pole, anything, a wall makes a 90 with the ground. So we know that. So we can't do anything just right there, but there's something that I want you to focus on. They give you the 70 here, right? This is not a good highlighter. I'm going to go back to my yellow. Right, that 70 is here. So maybe let's focus on this triangle here. Let's focus on that. Okay. If you look carefully here, there's a straight line right here. So that means that this angle right there, angle C in this case, right, can be found by just going, let's go out on the side here and just go 180 minus 58. And that is 122 degrees. So you now know that, let's write it in here. I'm going to use a red pen here. Right, that 122 is now going to make it inside the triangle. And I talked about this at the very beginning of this unit, talked about supplementary. So it's a huge help, right? Now, how many angles do you have in this triangle here? You've got 2. You can easily find this one up here, right? Because you just subtract these from 180 to get that third angle. So you're like 180 and 180 again. It's like, yes, a straight line measures 180 from end to end, and all angles in a triangle add up to 180 as well. Let's do this. This is step 1. So you know when you look back, it's like, what did we do first? Then I'm going to just go off on the side here and just show that I'm going to go 180 minus 42 minus 122. And that's going to add up to 16 degrees. This is step 2. So you're basically just filling in. It's like a chain reaction. You found this one, which allows you to find that one. And what do you have now? I'm going to put 16 in there. Do you have a pair? Absolutely, right? And it's going to be messy if I go, right? But now I have a pair. So step 3, found pair. What am I going to use? Sine law, right? I have this pair. I don't know. It's going to be too messy, but I'm going to give it my best shot here. This is my pair that I now found. So this is where it gets interesting. This is where you can go one way and my key goes another way. And it's okay. Because let's face it, the height of the tree is the same, right? If I go closer to that tree or further back, the tree doesn't change height, right? It stays the same. So I'm going to say this. Let's start. You would get a mark just for determining that this is sine law. So we're going to go sinus 16 over 70 meters is equal to, what should I find? Which side should I find? Because you can find this side, right? You have that angle across from that one. Or if you use 42, which one would you find? This side right there. It doesn't matter. Can I say this? It's as if you are standing here and your friend is standing behind you, right? From both perspectives, you can find the height of the tree, right? So I'm gonna use this one and find this. I'm gonna call this y. If you wanted to find this one, that's fine. So I'm gonna go sine of 122 over y. Let's go ahead and solve that. Y is equal to 70 times sine of 122 over sine of 16. I need to do that because I went a different way. Then that's 215.37. I'm okay with you rounding there. Technically, you would use all decimals, but I'm okay with that. So I'm going to underline this because it doesn't answer the question, but it definitely helps. Right? You now found this side. So if you do have a marker or a pen, I always like to say, right, exactly where it is on the triangle. It's right there. Now it gets too messy. So what I'm going to do is I'm going to focus now on the big one here. So step 4, find height. So the first 2 steps are like this, right? Just boom, boom, you find those. Then you need to solve for one of the sides. I chose this one. So let's draw out a triangle, right? The big one on the outside, this is the height of the tree. I know that this is 215.37. So you forget about the other one, okay? And this one I know is what? What's this one here? 42, right? Not 58. Because I'm choosing to work with the big one. So this is the one that goes in this corner. Right? So look at this. You have a pair again. Okay. Sine of 90 degrees over 215.37 is equal to that over x. Okay. Then you go x is equal to, boom. This is what I tell students. When you're stuck, just start solving for something, right? Like, I don't know, like okay, there's a triangle, I got this angle, I'll solve for this one, or try solving for this one. You choose, and you'll get there, right? So we get 144.11 meters. This is the height of the tree. Anybody do it already and found this one instead and got the same answer? Like found this side instead? Because I actually, let's not do that in our notes because it'll drive you crazy when you look at that. Because I want you to be able to, for the exam prep, right? Like you go back to these. So let's just for 1 minute here assume that I started with sine of 16 over 70 meters, right? But instead, I'm going to call this Z, side Z. So I got to use sine of 42 degrees over Z. I'm solving for this one. I'm not going to put Z on here because then it will make sense later when you look at it. So Z is this times this times this. Sine of 16, side Z. That is 169.93 meters. Obviously, it'll be shorter, right? This one will be shorter because you're closer now. So when you redraw your triangle, this is still the height. I'm now going to use the 58 degrees, and this is the side here. And so now your pair is there, and this is across from that. So let me it's not notes, so I can be messy. Okay. There. Cross multiply and divide. So I'm just going to show you that sine of 58. I'm not going to divide by sine of 90 because there's no point. And look at that, right? You get the same height because the height of the tree doesn't change. Okay. So there's that. Okay, let's keep going. My page came completely out of the booklet, so not good. Let's keep going. Let's go to our next, which is on page 273. You know what? You can use exactly what I just taught you now on this example right here. And I love it that it's facing the other way because sometimes that throws you off as well. Can I just say something? This 45, right? That angle right there is 45. And this angle right there is 50. So it's very cluttered here. So you need to find, like you almost need to redraw it, exaggerate a little bit, right? Where this is 45 and this is 50 here. This is B, A, C up here. So I maybe redraw that for yourself, right? So you know that this is really what we're zooming in. We're zooming in and this is the diagram. And this is 15 meters here. So what is the distance from Aiden's location to the top of the cliff? So they want this to the top of the cliff. They want you to figure out this side here. What is the height of the cliff? That is actually, right, this is the height of the cliff. I'm going to call this X. I'm going to call this Y. And then this is the toughest one. How far from the base of the cliff is Aiden standing? So if this is the base of the cliff, how far away from it is Aiden? So we've got 9 minutes. No, a bit more. 11. Want me to work through it with you? Yes, please, please. I know you like me talking, so I can't talk much at home, so I talk at school. There you go. Anyway, so this is a 90. You must agree. Say yes, it's a 90. Yeah, yeah, you're saying that. Okay. What is the distance from Aiden's location to the top of the cliff? That is side Y. I'm just going to make sure that if there are no letters, I'm giving it a letter. Okay. So I must do a couple things. I'm going to use a different color so you know how I got that. I'm going to focus on this triangle here because I have this side length. If this is 50, what is this? 130, right? Because it's along a straight line, so supplementary angles, it must add up to 180, so this is 130. Therefore, this must be 180 minus 130 minus 45. And that would be 50 minus 45, that's 5, right? Mental math, impressive skills, right? So you have your 5 degree up here. Very important. Don't be thrown off by something like that. It's just a small opening, right? So step 1, I use the supplementary angle property. Step 2, I use the fact that in a triangle, do this for yourself. A triangle always adds up to 180. So supplementary, then I use the triangle, then I have my pair. I'm going to use a highlighter for that. And I have my pair paired up there. That's my starting point. You need a starting point. Why can this not be cosine law? Let's just talk about that. How many sides do you need minimum for cosine law? You need minimum 2, right? SAS, or there's the SSS, which is clearly not the case. So I see my pair. So watch this. Sine of 5 degrees. Sine of 5, are you sure? Yep. Right? Over. What else which one of these two am I going to use? I'm going to use 130 because that is the angle across the side I'm interested in. And I don't have room to do it underneath, so I'm just going to do it right here. 15 times sine of 130 degrees over sine of 5. And you crunch those numbers, and you get 131.84, and we are in meters. Just watch the units. When I make my own worksheets, I go miles, kilometers, inches, you name it, feet. So there's that, right? So this was two steps right off the bat. And then this one you should know how to do and solve there. I will usually give you an A, B, C, D, E kind of scenario with this type of question. It's not just going to be do everything, right? And then how high is the cliff? So obviously it's side X for our diagram here. And what I'm going to do is I'm going to focus on, look up on the screen, okay? I'm going to focus on the big one. I'm not going to ignore this line right now because I know this side length. So I'm going to actually make a diagram here where this is 131.84. So it feeds into this, right? This angle right here is what? Just to make sure you're awake, this one is 45, not the 50. It's the 45 here. And if you notice anything about a 45, if this is 90 and this is 45, this must be 45. It's an isosceles triangle. But let's pretend like we didn't notice, right? So we want this. So this is our pair. Sine of 90 over 131.84 is equal to sine of 45 over x. So it's 131.84. I hope you write this down. sine of 90. Okay, so this, when you crunch those numbers, it's 93.22 meters. That's the height of the cliff. And you could have done it a different way, but I chose to use the big one and use that. How far from the base of the cliff is Aiden standing? So I'm going to make my diagram here. Watch how I'm going to do this one. I am going to use the same one as above. So 131.84. This is 93.22. This is 45. And let's call this Z. Okay. This is Aiden here. I'm going to use, you can choose, do you want this pair or you want this pair? I'm going to use this pair. Okay. How would you find Z? What angle do you need? You need this one up here. You use a pen because this angle you find by going 180 minus 90 minus 45. Right? So you know the 90, you know the 45, so this is 45 degrees also. Yeah. Ah. Yes. Side angle side. Yes. Yes. But could you, like, if this is 45 degrees and this is 93.22 and this is 45 degrees, what would you think this side would be equal to? 45? 45? Is this the same angle? It'll be the same size. But let's say we didn't notice that, because sometimes you don't notice, right? Yes, let's go SAS. Raphael is saying SAS, right? So if you want Z squared, you go 93.22 squared is 131.84 squared. Oh boy, I'm going to run out of room. So I'm going to reduce my font here to 93.22, 131.84. Cosine of 45. Yes, it worked. Z is square root. I'm going to have to crunch these numbers, so bear with me. And so what I would say is the page numbers that I gave you, you practice for tomorrow. Okay. So this is 86, 90, 89, 28, 25. Square root that. 93.22. What do you know? Right? You see that? Same as the one above, because 45 is the angle across from it. So if you had 60, 60, 60, all three sides would be the same. Okay. So homework. Practice at least one. Page 270. Page 274. And uh, 282. I will give you the answers tomorrow.